The Large Hadron Collider is the world's biggest atom smasher. It's possible that CERN has found something so amazing that it changes everything we thought we knew. This famous center has been at the forefront of important research since the 1950s, always pushing the boundaries of scientific knowledge. What does this shocking discovery mean for us? Let's learn more about this fascinating story. Putting the universe's secrets on display, the Large Hadron Collider is one of CERN's most well-known projects. It is the biggest particle accelerator in the world, spanning over 27 kilometers in a loop and costing more than $4.5 billion. Many people believe this money was well spent because the LHC has led to some of the most important discoveries in recent years, such as finding the Higgs boson and other previously unknown particles. Capable of over 11,000 laps per second, this massive machine accelerates different particles around its loop until they are almost moving at the speed of light. This is possible due to extremely powerful electromagnets inside the accelerator, creating a magnetic field more than 1,000 times stronger than the Earth's. Some people have been concerned that such a strong magnetic field could interfere with nearby devices or even affect the Earth's magnetic field. When these particles reach their top speed, 99.91% of the speed of light, they are made to collide with each other. These powerful collisions release a tremendous amount of energy, producing various new particles. These particle showers spread in all directions and last for only a fraction of a second before vanishing. Sensitive detectors are strategically placed around the impact sites to capture and record every detail of these high-energy interactions. These studies have yielded vast amounts of data, helping scientists understand the fundamental components of the universe. The work at CERN continues to push the boundaries of knowledge, making scientists question what they thought they knew about physics and leading to the development of new technologies and theories. What remains most surprising is how much we still don't know about the universe. The Large Hadron Collider is a hub where scientists from all over the world gather to collect and analyze interactions between subatomic particles. Researchers meticulously examine the more than 15 petabytes of raw data generated by these experiments each year. In 2017, the LHC marked a significant milestone when it stored over 200 petabytes of data in its tape banks. To put that into perspective, a petabyte is equivalent to approximately 250,000 full-length movies. Scientists continuously sift through this vast data pool, searching for anomalies. Recently, an unexpected phenomenon was observed with a type of particle called the beauty quark. According to the Standard Model, a widely accepted framework for understanding fundamental particles, the beauty quark should decay into lighter particles called leptons, which can be either electrons or muons. However, data from the LHC revealed something puzzling. Beauty quarks were decaying into muons 70 times more frequently than into electrons. Theoretically, this should happen about half as often as it does. This unexpected discrepancy has led some scientists to believe that there might be new physics beyond the Standard Model. It suggests the potential involvement of an undiscovered particle, which could drastically change our understanding of physics and help answer many unresolved questions. The Standard Model describes 4 fundamental forces, but only accounts for 3, electromagnetic, strong, and weak forces, while leaving out gravity and dark matter, which constitute most of the universe. The mystery surrounding the beauty quark's behavior could lead to groundbreaking discoveries, potentially uncovering aspects of physics we do not yet fully understand. Scientists remain highly interested in finding this new particle and exploring the forces it might reveal. This research holds the promise of providing deeper insights into the mysteries of the universe. New results from the LHC are challenging previous assumptions about particles and fundamental forces. Some scientists suspect that there may be an entirely new force at play, which could reshape our understanding of nature. A few months ago, the Large Hadron Collider detected data that did not align with standard particle physics predictions. While anomalies occasionally occur, this particular result caught experts' attention. They are now closely investigating its implications. There is growing excitement about Z prime, a hypothetical new particle that has never been observed before. Scientists speculate that it might be extremely weak, making it difficult to detect. If real, this new force could interact with electrons and muons in a way that differs from the known forces. If this force is confirmed, it could significantly impact our understanding of the universe. Researchers have spent years searching for clues that could help solve major cosmic puzzles, such as the nature of dark matter and the true role of the Higgs boson. Some even believe that this new force could unify all of nature's fundamental forces, one of physics' greatest aspirations. If Z prime turns out to be real, It could provide answers to some of the most profound questions in science. The ongoing studies at CERN might lead to a completely new way of understanding the universe. An intriguing experiment at the Large Hadron Collider involves accelerating particles to 99.91% of the speed of light before making them collide head-on. These collisions are not just scientific spectacles, they generate an enormous amount of new particles and energy. When the particles crash, they scatter in all directions, though most of them exist only briefly before disappearing. Highly sensitive detectors are positioned at the collision points to capture every detail of these short-lived interactions. These carefully placed instruments record massive amounts of data. Each year, the LHC produces more than 15 petabytes of information, which researchers meticulously analyze. The facility's tape libraries had stored more than 200 petabytes of data by 2017, a testament to the immense scale of this scientific endeavor. By sifting through this wealth of data, scientists hope to uncover revolutionary discoveries that could reshape our understanding of the universe. The work being done at CERN continues to push the boundaries of human knowledge, bringing us closer to answering some of the most fundamental questions about existence itself. By 2017, just to give you an idea, a baby can hold around 250,000 movies. They may ask you why they gather so much information. The action of a certain type of quark called the beauty quark is one of the many interesting things that have been found. A quark is the building block of matter. There are different kinds of quarks, and each has its own qualities. These types can change quickly and almost instantly become other particles. It only takes a trillionth of a second for the beauty quark to change, but recently, it did some strange things that scientists didn't expect it to do. Current ideas say that when beauty quarks change, they should each become an equal number of leptons, which are lighter particles like electrons or muons. At the LHC, beauty quarks changed into muons 70% of the time, which is a lot more often than into electrons. This strange discovery makes me think that these changes might be caused by an unknown particle, which could mean that there is new physics we haven't found yet. This could mean a new particle with a power we don't understand. This could change what we know and make the Standard Model, which is the main scheme of particle physics, bigger. The Standard Model is a good way to understand particle physics, but it's not perfect. These strange changes in quarks bring up big questions that make the model less full. There may be new basic forces or particles about to be found. The ongoing work at the LHC is not only studying the depths of particle physics, but it could also change how we think about the basic forces and structures of the world. Let us now look at how these new findings might affect our main theory of physics, the search for the elusive Z-prime particle. The Standard Model of particle physics talks about three basic forces, the weak, the strong, and the electromagnetic. It doesn't explain gravity or dark matter, though, which is what most of the world is made of. Scientists recently found something strange in their tests that didn't go as planned. Because the Large Hadron Collider, LHC, has so much data, it often gives experts results they didn't expect. This one in particular caught their attention and led to more study. Scientists think that this strange event could point to a new fundamental force and a new particle, which could be named Z-prime. This particle might carry force, but it is thought to be very weak, which is why no one has seen it before. Some people think that Z-prime might interact with electrons and muons in a way that is different from how known particles do. However, it is still not clear how it fits in with the other particles in the Standard Model. It would be a huge step forward in physics to find a new particle that can carry force. Some of the big questions about the world that it could help answer are those about dark matter and the Higgs boson. Some experts even think this could help bring the basic forces together, which is a goal that has been worked on for more than 100 years. A particle collider called the Large Hadron Collider was built by CERN from 1998 to 2008. Elon Musk praised their work on it. Over 10,000 scientists from over 100 countries worked on this huge project with hundreds of organizations. The collider is about 175 m below the ground in a 27-kilometer tunnel on the border between France and Switzerland, close to Geneva. The LHC has broken energy records since it started running. The first collision reached 3.5 teraelectron volts per beam, which was almost 4 times the previous world record. It was later made better so that each beam could hit 6.5 teraelectron volts. Musk said that the LHC can speed up both proton beams and lead-ion beams, though proton beams are the most common type. The LHC tries collisions between protons and lead ions once a year for about a month to look into different particle physics ideas. These ongoing tests are very important for learning about the basic building blocks and forces of our world. That's not all the fun there is to it. People all over the world who study physics are interested in the Higgs boson, which is often just called the Higgs. This very small particle is connected to the Higgs field and stands for the energy that comes from it, like waves in the ocean. It's different from other particles because it doesn't behave like basic particles or particles that carry forces like electromagnetic fields or nuclear reactions. Scientists have been working at the Large Hadron Collider at CERN, which is the world's biggest particle collider, to try to figure out what the Higgs boson is. It is here that very fast particles crash into each other, making new particles like the Higgs and exposing them. When scientists found the Higgs boson on July 4, 2012, they were very proud of their big accomplishment. They mostly found it by watching it break down into two types of particles, photons and Z bosons. Z bosons are particles that are involved in weak interactions. The story didn't end here, though. When the Higgs boson was found, it led to new questions in the field of particle physics. Experiments at the LHC, especially those by the ATLAS and CMS teams, have been learning more about the Higgs boson. The planned high-luminosity upgrade of the LHC in 2029 will make this study a lot more useful. This update will make it easier to find rare events that current theories might not fully explain. It will do this by increasing the number of particle collisions. Next, we'll look at how these new ideas affect studies that are still going on at CERN's quest for 15 million Higgs bosons. CERN thinks that they will be able to make 15 million Higgs bosons every year after the update, up from 3 million in 2017. This rise might help find different kinds of Higgs bosons. Some ideas say there could be up to 5 types, with some showing up less often than others. That being said, scientists already had strong proof for a type called the magnetic Higgs boson before these improvements. The trip doesn't end there, though. Scientists think that studying the Higgs boson will help them figure out more about the world. Every experiment adds a new piece to the puzzle, and the big discoveries that come from them could help us understand the basic forces and particles that make up everything. Scientists are getting more and more excited because they are about to make new discoveries that will lead to scientific progress and a better understanding of the world around us. The Higgs field was a very important thought right after the world started because it changed the way space and time are organized. This field is what makes matter behave the way it does and gives particles their mass. Space would be empty without the Higgs field and the Higgs boson. There would be no atoms, stars, or life. The media mostly gave the Higgs boson the name God particle after it was discovered. The dramatic name comes from Leon Lederman, a scientist. He first called it the God particle because it was so hard to find. Lederman wrote a book about it in the 1990s. He wanted to call it the God particle, but the authors changed it to the God particle to stay out of trouble. A lot of people had different ideas about how this name related to faith and science. The Higgs boson and its fields are very important. Particles would not have mass without them. There would be no galaxies, stars, planets, or life without mass. This is why the term, even if it's dramatic, makes it stand out. Higgs boson research is still going on to learn more about the early world and how it stays fixed over time. The Higgs field is unique because it gives empty space a base level of energy, which is necessary for the universe to exist. They believe that if they can figure out the energy of this field, they can explain why the electromagnetic force has an endless range but the weak force doesn't. By making pairs of these particles, they are also looking at how Higgs bosons interact with each other. It's still not clear what the Higgs boson's own mass is, even though it gives other particles mass. The idea doesn't fully explain why its mass isn't unstable because of changes in quantum mechanics, which would make space less empty. Scientists are always looking for more particles like the Higgs boson. Even though this won't happen for a very long time, finding these could help us figure out what the universe's basic forces are and could even lead to new physics that we don't know about yet. There's even more to the Higgs boson's complexity. Scientists are also trying to figure out how the Higgs field fits into the bigger picture of how the universe has changed and stayed stable over time. Getting more information is important because we need new physics ideas to explain how the Higgs boson's mass stays stable. It is also suggested that, when possible, higher energy colliders be used. Even after 10 years, this idea still keeps a lot of scientists busy all over the world. Scientists have been trying to figure out the Higgs boson for a long time. It was first suggested in 1964 and then found in 2012. It's puzzling why it took so long to be found. It's hard to find this particle because it's quite big and naturally unstable. A high-energy collider was used to focus a lot of energy in a small area so that it could be made. After being created, Higgs particles break down very quickly in a lot of different ways. However, Only a few of these breakdowns can be seen clearly because of other things going on in the background. As new science comes out, it leads to big questions and crazy ideas about what CERN does. Researchers made some of the biggest and most advanced devices to look for these particles as part of their quest to learn more about the Higgs boson. It took them hundreds of billions of proton collisions to find the Higgs boson's unique mark. This wasn't the worst part, though. Some people are still not sure if the projects and findings made at CERN will lead to big steps forward in science or, as some fear, to terrible results. People who believe in conspiracies have said some scary things about CERN's work. A common idea is that CERN's work with very fast subatomic particles could accidentally cause terrible things to happen, like opening a doorway to a dangerous world. That being said, CERN has stated that its work on making antimatter will help us learn more about matter and mass. It is made up of tiny particles whose charges are the opposite of those in matter. Some ideas about the Big Bang say that antimatter formed at the same time as the universe. Even though it's not common, antimatter should be as common as matter. It wasn't the only strange idea, though. Some people think that CERN's tests might change our reality, possibly sending our world into another dimension and messing up a lot of people's memories. This is called the Mandela effect. Last but not least, there has been talk about claimed human sacrifices at CERN since a video from 2016 showed a fake ceremony taking place on the grounds of the facility. Later, CERN said that this movie was fake. A lot of people talked about the video online, which showed people in hoods performing what they said was a fake ceremony. But a spokesman for CERN said it was just a bad joke. Scientists have mostly ruled these ideas out, but they are still the subject of heated discussion and interest about the scope and effects of CERN's experiments. However, this wasn't the end of the story. People talk about CERN's work and wonder what will happen next because it is so interesting. It's still not clear if the cops began an investigation after a very bad incident. People were interested in CERN again on July 5, 2022, which is not a surprise since it is often at the center of strange ideas. When things started up again after 3 years of upgrades and maintenance, the internet was full of different ideas. These ideas might be scary for science buffs, but it's clear that CERN's goals don't include making portals to other worlds, whether they are hellish, futuristic, or something else. Are we ready for what might happen if we find out what we don't know about particle physics? Leave your thoughts in the comments below, like and subscribe to Expedition Diaries for more.